So the first thing we need to do for this problem is to draw a picture. So we know that the police cursor is approaching the right angle or the right angle intersection from the north. So the police is going from top to bottom and the car turned and it's going east. So there's my police cruiser and then the car. So we are given that at this specific moment in time, the police is at 0.8 from the intersection, the car is 0.2. My rate of the police cruiser is 63, and at this specific moment in time, the rate that is increasing between them is 6 miles per hour, and we're trying to find the speed of the car, so DC. So if you notice my variables, I call this P, this is C for car, and then Z is the distance between them. So I'm going to use the Pythagorean theorem. So every single part of this triangle is changing. The police car is changing distance, the car is changing distance, and the distance between them is also changing. So if I take the derivative, I'm going to get 2z times the dz, which is the distance between them. Remember, these are technically all over dt, but I'm just excluding these for now because it makes it a little bit more complicated to solve. So I'm going to solve for dc. So solving for that and dividing everything by 2, I get this formula. So now I can do at a specific moment in time, at a snapshot. So I'm going to go ahead and substitute the information that I know. I don't know what z is, but I know that dz is changing at 6 miles per hour, p is 0.8, dp is 63, and then c is 0.2 at this specific moment in time. So all I need to do is find what z is at this specific moment in time. I'm going to use Pythagorean theorem. So using Pythagorean theorem, I end up with z is 0.82462. One of the things you do need to be careful with is you need to put in all your decimals. So I stored this in A. Remember how I taught you to store stuff on your calculator? Because otherwise your decimals are going to be off. So I'm going to go ahead and substitute this into my equation. The only other thing that I needed to worry about is my rate of speed for the cruiser. Remember, for these problems, direction does matter. Since I'm coming from top to bottom, the speed is actually negative 63 miles per hour, and that's going to make a difference on my equation. My answer, because I'm going to the right, it's going to be positive. So the car is going to be in the positive direction. So if I solve for this, I end up with 276.74 miles per hour. So the car is going at 276 miles per hour.